Hi, Advanced Algebra students. Today we are talking about the standard form of a quadratic equation or a quadratic function. So what that looks like is y equals ax squared plus bx plus c. A is the coefficient of the quadratic term, b is the coefficient of the linear term, and then c is the constant. We're going to begin with just investigating in Desmos what these different values are doing to a graph. When we think about lines, we can identify x1 and y1 or a point on the line or m as slope. So how are these coefficients relating to different parts of a graph of a quadratic? Okay, so I have our standard form and I've created sliders for all of these values, and just to see a little better, I'm going to make it projector mode. Okay, we have talked about A. A is the stretch factor for the graph, and so as A grows larger than 1, it appears to be skinnier, as if it's being pulled vertically. And then if A is between 0 and 1, that graph is starting to get wider. And then we talked about how if A is negative, it's going to do a reflection, but just in the opposite direction. So you still get skinnier or you get wider, but it's now facing down. Do you see what happened when A was 0 there? If A were 0, this term cancels and you're just left with the linear equation bx plus c. So we're talking about quadratics where A is not 0. Okay, so A does what we kind of expected. It's the stretch factor of the graph. Now let's look at B. For B, oh, that's kind of weird. So B, it's almost kind of rotating up and around this y-intercept. So the y-intercept does not change no matter what the B value is. What is changing is the intercepts, the x-intercepts of the graph change as we change B, and also the vertex and the axis of symmetry. So B is playing a key role in some of those key or important parts of our graph, but not the y-intercept. C. What is C doing to the graph? Oh, okay, so C is just shifting the graph up and down. And it appears to be that whatever the y-intercept is the C. Okay. Algebraically, that makes sense because the y-intercept is when x is 0. So if you were to plug 0 in for these x values, you get a times 0 squared plus b times 0 plus c. And so you end up just getting y equals c. So that looks like a nice shortcut that we can use algebraically, is that c is always just going to tell you what the y-intercept is. B, it's going to create a little bit more work for us as far as what that does. I'm going to go ahead and tell you the axis of symmetry. Had I been here, we would have probably done an investigation. But this equation of negative b over 2a equals x, that's going to be the equation for the vertical axis of symmetry. And so as I change a, and a stretches the graph, it's kind of pulling that vertex out and in. And then as I change b, b is also kind of sliding our graph to the left and to the right, but not really a horizontal shift. B is also playing a role in where the axis of symmetry is. C is just sliding the graph up and down that axis of symmetry. So C doesn't have anything to do really with the axis of symmetry. But what it is important to know is that the vertex lies on that axis of symmetry. So negative b over 2a is the expression that can be used to calculate the axis of symmetry. And it's also the x value for your vertex. Okay. So that's helpful when we begin to plot equations like this, is that we can use this calculation as our shortcut. Okay, we are going to go back. Yes, I believe you. And we're going to fill in our foldable. And today we're talking about the standard form. So the standard form looks like y equals ax squared plus bx plus c. We just talked about how the axis of symmetry can be found with the calculation of the opposite of b over 2a. And it's important to remember that the axis of symmetry represents a line, so you always need to write this as a line. It's x equals and then a number. Okay. How to find the vertex? What you want to do is first find your axis of symmetry, and by doing so you found the x value of your vertex. So you will substitute the axis of symmetry value into the equation to find y. We're going to notate that as an ordered pair. The x value is negative b over 2a, so it's just the x value from the axis of symmetry. And then for the y, I'm going to notate it with function notation, f of negative b over 2a. And what that means is we're just going to evaluate the function, this equation, at the value of negative b over 2a. Okay. Miscellaneous is like, what additional information will this standard form tell us? This standard form will give the concavity. And so by identifying if that A is positive or negative, we can tell if it's going to be an open up or open down parabola, and if that vertex is a maximum or a minimum. It's also going to give us the y-intercept. Okay, the y-intercept is just the ordered pair 0, c. Lastly, we're going to talk about the graph in standard form. So I'm just going to make a rough sketch here of, this is just some random parabola. Okay. The vertical line is your axis of symmetry. So that's the line x equals negative b over 2a. And so what we want to do when we graph standard form is find that value. And by doing so, we can find the vertex. And then we're going to use the y-intercept, which is 0, c. And then by symmetry, we can find another point on our line and use those as our 3 points to plot. Now let's say your vertex is that y-intercept, or the vertex and the y-intercept are like very, very close together. What you can do is use that stretch factor of a to find points on either side. Okay, so in steps, what we're doing, I'll zoom in a little bit. We want to find the vertex. So that's going to create or require some algebraic work behind it. From there, we're going to plot the vertex and the y-intercept. And then lastly, use symmetry to find our third point. All right, from here, let's do an example. Okay, let's say we have the equation y equals negative 2x squared plus 8x minus 5. And we're asked to graph this quadratic, find its key features, and then kind of take a look at it. So let's start with finding the axis of symmetry. That would be x equals the opposite of 8 over 2 times negative 2. This is kind of coming from negative b, in which case ours is negative 8, and then dividing by 2 times a. Our a value is negative 2. So it's the negative b over 2a calculation. We get negative 8 over negative 4, which is 2. So our axis of symmetry is x equals 2. Once we have the axis of symmetry, we can find the vertex. To find the vertex, we're going to substitute 2 into this equation and find the corresponding y value. So this is negative 2 times 2 squared plus 8 times 2 minus 5, which is, let's see, negative 4 times 2, negative 8, plus 16 minus 5. And we get 8 minus 5 is 3. Y equals 3. So our vertex is the ordered pair 2, 3. Lastly, we can use the y-intercept. The y-intercept doesn't really require any work, it's just the c value of our equation, 0, negative 5. And when we plot the y-intercept by symmetry, we can find a third point on our graph. So I want you to do all graphs during this chapter on graph paper. So our first example here is y equals negative 2x squared plus 8x minus 5. And we did our work to find the vertex. The vertex was the point 2, 3. And from that vertex, I want to get a picture of, is my graph going to be opening up or is it going to be opening down? Based on the a value, since a is negative, that tells me that I'm going to be having a downward facing parabola. That coincides with that y-intercept, which was negative 5. I've plotted my axis of symmetry as a vertical line. That's the line x equals 2. And what I talk about with symmetry is our y-intercept was 2 units away from the axis of symmetry. So by symmetry, 2 units to the right is also a point on our line. And approximate our graph from there. Okay, so that would be a good picture of your graph as long as it's including that work as well. Okay, that's it for tonight.